Find inverse Laplace transform of pi u s plus 3 divided by s minus 1 divided by s minus 1 and s square plus 2s plus 5. Okay. Now I will consider the given. Once again, one thing you can notice, degree of the numerator is 1, degree of the denominator is 3. So by partial fraction method, we can write the term for us minus 3 divided by s minus 1 into s square plus 2s plus 5. Now, for the first, what I will do, by linearity, I will write a upon s minus 1. Is it okay? Okay. So what about the second one? Now, one thing you can notice here, this term, that is s square plus 2s plus 5, here it is not possible to find the linear factors because we have to split this 5 into two numbers a and b such that their product is 5 and their addition is 2. It is not possible. So that's why for the second term, I will consider that quadratic factor as it is. That is s square plus 2s plus 5. And for quadratic, what I should take in the numerator? Yes, Shravani Mali. What I should write in the numerator?
Yes, sir.
What I have to write? What I have to write? I am writing simultaneously. Read at least.
BS plus C.
Okay, because of the quadratic. Now, in this case, suppose I will take the cross multiplication. That whole equation you have to multiply it by the denominator factor. Then the same thing we can write 5s minus 3 is equal to a into bracket s square plus 2s plus 5 plus bs plus c into s minus 1. Either you can put the value by 2 or 0 directly in this, but to calculate the next derivative, we have to convert it into 6. Why we have to convert it to 1 plus tan square? Because the derivative of 6 square is first of all 2 times sec x. The derivative of sec x tan x. So we will get 2 times 6 square x. Okay, so instead of avoiding this, so we will put 6 square to be 1 plus tan square. So here we have 1 plus tan square. What is the tan of? Hello? Hello? I'm audible? Hello? Hello?
Yes, sir.
Okay, let us continue. Now it's okay, na? Now let's continue.
Sir, question मध्ये 5s plus 3 आणि we can write 5s minus 3 लिहिलं आपण.
Because this is plus, this is also plus. And the right side, if we simplify, it is as square plus 2as plus 5a plus, in the same manner, if we simplify this term, what happens? bs square minus bs plus cs minus c. So collecting similar term, if you collect similar term, then the first a plus b into s square. That is the terms of s square together. The term of s square together. Plus, suppose s term 2a minus b. Okay, one more term I have to write. Plus c into s. Okay, means I am collecting the terms of s together. This term, and this term. And the last one is 5a minus c. Okay, equating the coefficients. Equating the coefficients. Equating the coefficients, we will get a plus b is equal to. Anyone help me to write the right side term? 2a minus b plus c equal to 5a minus c equal to. Can anyone help me to write the right side term?
A plus B is equal to 0.
A plus b is equal to 0. Next one, 5. Next one, 3. Correct now? Now, to find the constant a, I will use the regular method. That means because a is a linear factor, na, where this a can be written as 5s plus 3 divided by s square plus 2s plus 5, and value of this function at s is equal to, yes, what is the term? This one is 5 plus 3, 1 plus 2 plus 5. What is the final term? 8 divided by 8. That means you are getting a is equal to 1. That first constant, a is equal to 1. Okay. Now, why I am finding a separately? That value you can substitute in equations. Okay. Try to find other constants. Okay, next one. So here what I will do, I will substitute the value of b here. I will substitute value of b. So b is given as minus a. That is b is equal to minus 1. So directly you are getting b is equal to minus 1. Okay. Now in this formula, if I substitute the known values, or suppose this one, anyone, only c is remaining, na? So c is given as 5a minus 3, that is 5 minus 3, that is c is equal to 2. C is equal to 2. Okay. Now these values I will substitute. Therefore, inverse Laplace transform of 5s plus 3 divided by s minus 1 s square plus 2s plus 5. So this is given as L inverse. Simultaneously I will use the linearity property, which is given as L inverse of 1 upon s minus 1 plus second term is, I will substitute the value of b is minus s plus 2 divided by s square plus 2s plus 5. Is it okay? Now further, this term by linearity property I will write this as L inverse of 1 upon s minus 1. Now here I will take negative common, and it becomes L inverse of that negative sign I will adjust in the numerator, s minus 2 divided by s square plus 2s plus 5. Now here, this one is e to the power t minus L inverse of this. I will write s plus 1 minus 3. Is it okay? Now further, this is s plus 1 bracket square. This one is s square plus 2s plus 1 plus 5 minus 1. So further, e to the power t minus L inverse of this I will write as s plus 1 minus 3 divided by s plus 1 bracket square for this plus 4, right? Now further, this one I will write as e to the power t minus by first shifting theorem. This I will write L inverse of s minus 3 divided by s square plus 4. So further, this one I will write as e to the power t minus e to the power minus t into bracket L inverse of s divided by s square plus 4 minus
हे फक्त इथं आहे डेट हे झाली चेंज करतो आणि हे एक्सचेंज करायला सांगितलं क्लिअर सर.
hello. The second one is L inverse of 1 upon s square plus 4. Okay. Further, it can be written as e to the power t minus e to the power minus t into first I think cos 2t minus 3 into 1 upon 2, right now? 1 upon 2 into sin 2t. Okay, just I am taking these examples, students are joining. This is the final answer. So few example I will write as a homework. This one is 13. These examples you have to complete as a homework. One example you can complete here 14th only. The remaining you can complete as a homework. So find L inverse of 2s square minus 6s plus 5 divided by s cube minus 6s square plus 11s minus 6. Okay, that is 14th. Next one, 15 suppose. So find L inverse of 2s minus 4 divided by 6s square minus 5s plus 1 bracket raised to 4. And I am assuming that all of you are solving these examples as a homework. 16. Find L inverse of 6s minus 4 divided by s plus 1 into 2s plus 1 bracket square. 17th. Find L inverse of s square divided by s square plus a square, s square plus b square, and here it is given that a is not equal to b. So take 3 to 4 minutes and try to complete that Hello. Yes. So let us continue with the convolution theorem. This is just students are joining. That's why I started with the partial fraction. This is almost end for the partial fraction method. I think 27 students have joined. So the next one is inverse by convolution theorem. Inverse by convolution theorem. Now see the statement. What is the statement of the convolution theorem or the definition? So definition for convolution theorem, it states that here I will use a capital notation, okay? So if f of t and g of t are the two functions, then the following integral. What is the definition for convolution? Means mixing. If suppose f of t and g of t are two functions, then the following integral, then the following integral, see the combination how it is given, following integral. So that integral is given limits from 0 to t, definite integrals are independent of the parameter. Here I am writing f of u into g of t minus u du, okay? G of t minus u du is sorry, is called convolution of the two functions. What are the function? First one is f of t and second one is a g of t. So again and again I'm telling, definite integrals are independent of the parameter. Okay, g of t, and the convolution is denoted by and it is denoted by, see, for capital F I'm using F and star G, okay, F star G, that is a convolution. So can anyone explain how will you write G star F? Similarly, suppose you want to write G star F. Guess anyone? Pradnya Surve. Limits once again comes as a 0 to t. Pradnya?
Yes, sir.
Can you complete the integral part? See, integral is with respect to u. You have to compare the G star F means convolution of G and F. Quickly. First function is G. So you have to write G of u. Okay. Second function is F. You have to write F of t minus u, and integral is with respect to u. Okay. This is a convolution. Such type of integration is called as a convolution of the two functions. So the next theorem to find the inverse Laplace by convolution theorem. So see the statement. So let Laplace transform of, I am using capital notation, f of t is equal to f of s, and Laplace transform of g of t is equal to g of s. Then suppose we have to find inverse Laplace transform of f of s into their product I am taking g of s. Now see the statement, the same statement you can write f of t is equal to L inverse of f of s. and g of t is given as L inverse of g of s. Okay, same thing. Then the inverse Laplace transform for the product is given by the integral 0 to t f of u into g of t minus u du, or the same integral can be calculated either first or second. First or second, this can be written as f of t minus u into g of u du. This is by convolution theorem. So it can be written as f star g or g star f. Both are equal. Okay. So this theorem you have to use. This theorem you have to use to apply or to find inverse Laplace by using convolution theorem. Okay. So I will take one example, then you will get a better idea. So proof we are not studying, because if you go through the syllabus, clearly it is mentioned that convolution theorem without proof. So the first example, find inverse Laplace transform for 1 upon s plus a s plus b by convolution theorem. Same example you can find by using partial fraction also. Okay. Now here you can notice that I will consider 1 upon s plus a as a first function and 1 upon s plus b as the second function. Okay. Suppose, so let f of s is equal to, because their product is original function s plus a, and g of s is equal to 1 upon s plus b. Is it right? If this is so, then L inverse of f of s is nothing but L inverse of, what is your f of s? 1 upon s plus a. Yes, anyone can tell? Sakshi, what is L inverse of 1 upon s plus a? E raised to L inverse of g of s is given as L inverse of 1 upon s plus b. Is it right? So further it can be written as e to the power minus bt. And this function I will call as a f of t, suppose. I am denoting the notation. And this function I am denoting as g of t, suppose. Okay. So capital F of t and g of t is given by. Therefore, by convolution theorem, L inverse of the product, what is the product? F of s into g of s is given as, see, I will use our result 0 to t. Now see, whether I have to apply the first result or the second result, that you have to decide by looking to the term f of t and g of t. But in this case, both are same. Both are exponential. That's why you can use first or you can use second. Suppose I'm using first. I will write f of u into g of t minus u du. That means what is the product here in this case? L inverse of f of s into g of s, that will become s plus a and s plus b. Now, to the right side, integral 0 to t. Can anyone tell what is f of u? Now see, I will highlight the function. This is your f of t, but I have to write f of u. Yes, Pranoti, what is f of u in this case? What you have to do?
E raised to minus a.
Right, exactly. E to the power minus a. What you are doing? You are replacing, see, you are replacing this t as a u in the given function. So right side also you have to replace this t by u. So it can be written as e to the power minus au. Am I right? Similarly, for the second, what you have to do? You have to replace this t by t minus u. Means to the right side where you are having t, that t you have to replace by t minus u. Then Sasmit Kulkarni, can you tell what is g of t minus u? I will write simultaneously. Minus b as it is. Okay. Susmit or Sasmit? Okay,
Susmit, sir.
Susmit. Hmm.
Sir,
What I have to do?
T
This t, I have to replace by this t minus u. I have highlighted that
minus b t minus u, sir.
ah,
E raised to minus b t minus
t minus u and finally integral with respect to u. Understood everyone?
u. Yes, sir.
Now, this one I will write integral 0 to t e to the power minus au into e to the power minus bt into e to the power minus minus plus bu and du. What I did here? So I'm separating the term. Now my question is, can I take this term outside the integral? Because you are integrating with respect to u. With, with respect to u, other variables are constant. Can I take outside the integral? Yes,
Yes, sir.
because that we can consider as a constant with respect to u. So that's why that I will write outside. E to the power minus bt into integral 0 to t. Now the remaining term, because the remaining term involving u and integration is with respect to u. So that term I will write e to the power minus, I will take common, I think a plus b into u with respect to u. Is it right? So these two terms I am collecting together. Basis same, addition of the power. So further it can be written as e to the power minus bt into, yes, can anyone tell me the integral of this term? After integration, you have to substitute limits t is equal to 0, sorry, not t, it is u, because integration is with respect to u. So finally you have to substitute u is equal to 0 to t. Yes, I will take the name. Yashraj, can you tell the integral? I will highlight the integrand. What is the integration of this term with respect to u? Yes, Ankita.
Yes, sir.
Hmm.
E raised to minus in bracket a plus b u upon minus a plus b.
Very good. So e to the power minus of a plus b into u divided by minus of a plus b. Now what you have to do now for the remaining, you have to substitute upper limit and lower limit. When you substitute, upper limit means you have to replace u as a t. If you replace u as a t, then it will become e to the power minus a plus b upon t divided by minus of a plus b. This is upper limit. Lower limit you have to subtract, and anything raised to 0. If you substitute u is equal to 0, anything raised to 0 is 1 divided by minus of a plus b. Am I right? Verify the calculations. Sakshi, what is the problem? Many time you are joining the meeting once and out, going out, coming in. Okay. Simplify the term. Okay, continue. So this term, denominator, I will write minus of a plus b. So what is the simplification? Just I will add the power. Everywhere base is same. E to the power minus bt. I did mistake anywhere. I did mistake here. Yes, anyone can rectify, because what I require, I will highlight. I require e to the power plus bu. But when I solve the bracket, I think I am getting e to the power minus bu. So that's why. So here, 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 everywhere, that term is minus. I will rectify that. So a minus b. This is also a minus b. Then denominator is also a minus b. This is also a minus b. A minus b, a minus b. I think, is it okay? Now adding the power. Then in this case, the remaining term is only e to the power minus 80 minus of a minus b. Okay. Now second term become plus. Why I am writing plus? This one is also minus, this one is also minus. And outside the term is multiplied by e to the power minus bt. Now I think that we will consider as a final answer. So first one, e to the, this positive term I will write e to the power minus bt divided by a minus b, and this minus e to the power minus 80 divided by a minus b. I think further simplification is not possible. So that's why we can write, therefore, inverse Laplace transform of 1 upon s plus a s plus b is given as e to the power minus bt a minus b minus e to the power minus 80 divided by a minus b. Okay, that is the answer. So any question up to this? If not, I will give one part as a homework. Suppose here, instead of this, if I apply L inverse of f of s into g of s, can be integral 0 to t. Okay, that second result I am writing. f of t minus u into g of u du. So complete and try to find the answer and finally compare your answer. If you are applying the second integral, then also you will get same answer. Okay, if you are applying the second result, then also you will get the same answer. Any question? If not, I will continue the second example. Suppose second example, find inverse Laplace transform of s upon s square plus 4 bracket square by convolution theorem. Okay, you have to apply convolution theorem. Now, so what is your selection for f of s and g of s? Let your f of s and g of s, they may be interchange. Yeah. Suppose f of s, I will take s upon s square plus 4, and g of s I will take 1 upon s square plus 4. Is it okay? So their product is s upon s square plus 4 bracket square. Okay. Now, who will tell the inverse Laplace transform? Therefore, L inverse of f of s, that means L inverse of s upon s square plus 4. What is the answer? Desai? Okay, Ritesh Pednekar.
सर 1/2 sin 2t.
नाही रे, इथे यस आहे. कॉस्ट मध्ये येणार ना बाळा हा. This is
sorry.
s cos 2t directly. Okay. This is cos of 2t. Similarly, and this one suppose I am calling as a f of t. Okay. Second also, inverse Laplace transform of g of s is given by L inverse of 1 upon s square plus 4. Okay. Now this one is सांगा कोण सांगतील? प्रज्ञा सुर्वे. सेकंड टाइम घेतलो का नाव तुमचा? प्रज्ञा.
Yes, sir.
What is the inverse Laplace?
Sine 1 upon sine 2t.
1 upon a means 1 upon 2 into sine
1
2t.
upon 2 sine 2t.
Okay, suppose this is
G
g
of
of
t.
t. Therefore, by convolution theorem, L inverse of their product, L inverse of f of s into g of s is given as, yes, L inverse, or first I will write, suppose the integral, it is given as, this I will cancel, by convolution theorem, it is given as integral 0 to t f of u into g of t minus u du. Same result I will apply because both are same, either first or second you can apply. Okay, but what is the product here? Therefore, L inverse of the product is f of s into g of s is given by s upon s square plus 4 into 1 upon s square plus 4, it becomes square, integral 0 to t. So who will tell what is f of u in this case? Namrata?
Cos 2u.
Okay, cos of 2u. Okay, you have to replace t by u. Next one, Vardhaman Chavan, or what is the name? Vardhaman.
Yes, sir.
G of t minus u, you have to tell.
1 by 2 sine 2 t minus u.
Very good. 1 upon 2 sine of 2 into t minus u and integral with respect to u. Now from this, what I will do, see, from this, here I will take 1 by 2 as a common. Integral 0 to t. Okay. Now this one I will write as cos of 2u into sine of 2t minus 2u du. Now one more thing I will do, I will multiply by 2 and divide by 2. Okay. And next I am going to apply the result to, yes, what is the result? 2 cos A sine B. Yes, anyone know? I don't know the result. Just can anyone help? Yeah. Yes, you can Google it and tell me. I am not recalling. This one can be written as 1 by 4 integral 0 to t. Reverse CD formulas you are using. Product can be converted in sum. I think it is a sine plus sine. It is. Yes, anyone want to say sine plus
Sin A plus
Sine a
B.
plus b plus
Plus b.
sine a
Sin A
minus
minus B.
A plus B sine A minus B. Very good. Now in this case, suppose this one is your A. Okay. This
Plus
one is,
sign.
yeah, something is wrong. And suppose
In the middle minus sign.
in the middle minus, okay. In the middle minus, it means in standard result you are telling that minus. Okay. Just I will check. It's minus sign. Okay. So what is A plus B in this case? Addition of the angle. 2u plus 2t minus 2u. And what is A minus B? 2u minus 2t minus minus plus means 4u minus 2t. Is it okay?
Yes, sir.
Okay, by applying this result, then it is given as sine of a plus b. So that can be written as 2t minus sine of a minus b, that is 4u minus 2t, and integral with respect to u. So next step, suppose I will use a linearity property for the integral. This outside 1 by 4 as it is. Okay. Now you can notice the first integral. This sine 2t, this term is constant with respect to u. Okay, this term is constant with respect to u. So that's why that term I will take outside the integral, and integral 0 to t du minus second one, integral 0 to t sine of 4u minus 2t integral with respect to u. So once again outside 1 by 4 as it is, this sine of 2t as it is. Now this is a definite integral with integrand is 1. So evaluation of the integral is given by upper limit minus lower limit, that can be written as t only. Second, integration of sine, yes, anyone, is minus cos, is it right? 4u minus 2t divided by integration of 4u divided by derivative of 4u minus 2t is 4, and limits for the integral is from 0 to t. Okay. Now further, this 1 by 4 outside, and first term is t into sine of 2t. Now this term 1 by 4, why I am writing plus? This is minus, and this constant is taken outside. Now next I will use a bracket, evaluation of the term at upper limit. If you substitute u is equal to t, what is evaluation? This one. Yes. Namrata. Okay, Neeraj. I connected now. Hello.
Yes, sir.
Okay, Sakshi, you can continue. What is evaluation at upper limit?
Cos 2t.
Yes, very good. Simple, na? This is cos of 2t. Okay. Minus lower limit you have to substitute. Cos of minus 2t. Is it right? Verify my calculations. I may be wrong. Huh? And one thing you can notice, cos of minus theta is cos theta. So that's why this term and this term get cancelled. So the final answer is t by 4 into sine of 2t. So it is L inverse of S upon S square plus 4 its bracket square. So that is the final answer. Is it okay? Sometime it will be better, because see what happens if you are going to apply partial fraction method, this example become complicated because quadratic factor is repeated. So the power is 4. Sometimes it's become difficult. In that case, we can use convolution theorem to find a inverse Laplace transform. If not, I will continue with the next example. Third, find L inverse of 1 upon S into S plus 3 bracket square by convolution theorem. Now, Now, some students should unmute and tell me the answer. What is your f of s here? Selection. Let. What is your f of s? I think Shubham Patil. What is f of s and g of s? Shubham Patil. Means they are not there. Next, Rishabh Jha. Rishabh. Shubham Patil. Don't know, sir. Very good. You have to tell the answer. I will highlight. My choice for f of s is. I highlighted the term. Shubham Patil. Now I highlighted the term. Okay, no. Still your answer is don't know. So few students they are attentive. Total 29. Shravani. Yes, Sakshi, you want to say? F of s and g of s? Sakshi, I think you are unmuted. That's
Yes, sir.
F of s and g of s.
1 upon s, 1 upon s plus 3 whole square.
Yes. 1 upon s and 1 upon s plus 3 whole square. Therefore, inverse Laplace transform of f of s is given as inverse Laplace transform of 1 upon s. Yes, yes. What is inverse Laplace transform of 1 upon s? The result should be with you.
1, sir.
Yes, very good. It's 1. Then next one, L inverse of G of S is given by L inverse of 1 upon S plus 3 bracket square. Yes, anyone, it is open to all. Unmute and tell.
E raised to minus 3t.
Only that much? By shifting theorem, it can be written as e to the power minus 3t into L inverse of 1
by
plus s square. Now further, it can be written as e to the power minus 3t into inverse Laplace transform upon s square. Suppose this one I will call as a f of t, and this one I will call as g of t. Okay. Now, by convolution theorem, again their product is, therefore, by convolution theorem, L inverse of f of s into g of s is given by, one result says that 0 to t f of u into g of t minus u du. Okay. And second result also says that integral 0 to t f of t minus u into g of u du. So whether I should go with number 1 or number 2? Yes, anyone comment? Purposely I written for this example both, because the choice is important. Both the cases give the same answer. But what is your choice?
So number 2.
Yes, number 2. I think Sakshi, huh? Why? Very good. Why? Why you are feeling that number 2 becomes easy if you compare with number 1? Yes, you want to comment on this? Sakshi, na? Vardhaman say it is f of t is equal to 1. Very good. Because what happens when you replace t by u or t by u minus t, that some function remains same, always remains same. So that's why I will select for second result. Okay. Because of constant, it is independent of u. So that's why, suppose the second integral, if you are applying integral 0 to t, f of t minus u is 1 always. And the second one, you have to replace t by u, means it becomes e into e to the power minus 3u du. Am I right? So further it can be written as integral of 0 to t e into e to the power minus 3u du. I think one standard result you have studied, integration of uv with respect to x, suppose, where this uv says that after some derivative it vanishes, then continuously its integration is given by u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4 plus dot dot dot, where dash stands for derivative. Dash stands for derivative, and the suffixes I will highlight. Dash means this one, pink color I am highlighting, these as a derivative, and yellow color suffixes, these are nothing but the successive integrals. Now in our example, what is your choice of u? That u itself, because when you are taking derivative with respect to u, after some derivative it vanishes. So it can be written as equal to first term as it is. It is better to write a bracket into. So v1 means integration of e to the power minus 3u. बरोबर है? बरोबर है? First term. Next one is a minus. So what is the derivative of u with respect to u? I will highlight. You are taking derivative of u. This is a derivative. So again in bracket, integration of this v2 means integration of v1. So this integration you have to take. So already 1 upon minus 3 is there. Integration of e to the power minus 3u is e to the power minus 3u divided by minus 3, it becomes square. Next term is plus. If you are writing, what is the evaluation of the next term? If highlighted derivative, if you take derivative of the constant term, is 0. So that's why not necessary to write the next term. And limit of the integral from 0 to t. Once again, first term is minus u by 3 into e to the power minus 3u minus e to the power minus 3u divided by 3 square is 9. Limits from 0 to t. If you substitute upper limit, it becomes, first I will evaluate the term at upper limit, minus t by 3 e to the power minus 3t minus, make me correct if I am wrong, e to the power minus 3t divided by 9. So this is the evaluation of the term at upper limit. Lower limit you have to subtract. When you substitute u is equal to 0, that becomes 0, minus anything raised to 0 is 1, it becomes 1 by 9. So after simplification, that answer comes as minus t by 3 into minus 3t minus e to the power minus 3t divided by 9. I think last term that minus become plus. So this is L inverse of, for which term you are getting? 1 upon s into s plus 3, it's a bracket square. That is the final answer. Okay. Any doubt here?
No, sir.
Now, so by this weekend we have to complete the syllabus. That's why I think Afia joined earlier. I asked her, is it all of you ready if I take extra lecture at 3:30 today? Means Laplace we finish. Tomorrow we are having 2 lectures. Just write in the chat box if you are ready. At 3:30. Okay, you can leave.